All right, everybody, welcome to the first week. All right, welcome to the first week of TC362, Web Server Administration. I'm your instructor, Jeff Ciardo, and I'm going to be taking you guys through this course for the next 15 weeks or so. And last week, you should have already gotten started on getting a few things set up, including GitHub and Rackspace and some other little things. And we're going to go over some of that today once we get into more of the lab section. Now, this class is typically taught in person, but we've moved it to an online section because I'm not local in East Lansing this semester. So it's going to be a little bit different than I've run it in past years. But generally the topics are going to be the same, and I'm going to kind of split the videos up into kind of lecture and lab videos. So there'll be a little bit of slides that we'll look at, and then there'll also be some sketching and drawing, and then finally there'll be some actual live screencasting of working with these servers, and you will kind of experience all of that as we go through the semester. So without further ado, let's start off with this week's lesson. And today we're just generally going to talk about web servers. In this particular lesson, it's entitled Web Servers, Physics, and Entrepreneurship. And I'm going to kind of talk about where web servers came from, why we need to care about them, how physics is involved with that, and how these web servers that we deal with today have really changed the face of entrepreneurship, particularly web-based entrepreneurship. So, the class, like I said, is TC362. If you follow me on Twitter at @jciardo, you can look for class announcements and just general interesting links by following me and looking for the hashtag #TC362. And I won't make any major class announcements over Twitter, but if you're interested in kind of keeping tabs on what's happening in the server industry over the course of the semester, go ahead and watch that. Go ahead and watch my Twitter handle or this hashtag for updates. All right, we're going to skip that slide and go right into a brief history of web servers. So web servers had to come from somewhere, and they had to serve some type of purpose. They didn't just happen to be there one day because someone on a computer was bored. So our journey in web servers really starts with this man right here, Sir Tim Berners-Lee. And Tim Berners-Lee was a researcher at CERN. And while he was at CERN, he was struggling with how to kind of mesh his hypertext that he has been working with, which kind of later became HTML, with the broader internet. So at this point, around 1989 or so, when Tim Berners-Lee kind of first started proposing these web servers, the internet was still very much in its infancy. However, it did exist. So Tim Berners-Lee didn't invent the internet. Tim Berners-Lee invented the World Wide Web. So what he did is he took the underlying internet protocol and matched it with his hypertext protocol. And basically what we got out of that was CERN HTTPD, the very first web server. So the very first web server simply took the underlying protocol of the internet and kind of attached the hypertext protocol to that and allowed us to basically distribute documents in a standard format over the web. And that was the primary concern of Tim Berners-Lee at the time, was how do we share, distribute, collaborate, and cite documents, scientific research documents, because CERN is a scientific research institution. How do we manage all of those documents via the internet? And this is where CERN HTTPD and subsequently the World Wide Web was born. So after that, the next major web server we saw was the NCSA HTTPD. And this was really the precursor to the modern web server that we see today. So NCSA is the National Center for Supercomputing Applications, and this is a research center at the University of Illinois at Urbana in Champaign, Illinois. And in and around the early 90s, a group of researchers there developed this web server based a lot on Tim Berners-Lee work at CERN and kind of building on that. And at its peak, NCSA HTTPD was the most popular web server on the internet. In fact, about 95% of all websites at the time were hosted by the NCSA HTTPD. So this went on until about 1997 or 1998, and NCSA around that time released their final version, and then at that time a lot of that code base moved on to what we now know as Apache, or the Apache web server. And the Apache web server is really kind of the grown-up version of the NCSA HTTPD server, and it remains today one of the most popular web servers. It probably runs 90% of the internet. It's probably involved or the primary web server in most of the websites that you visited today. There are lots of exceptions to that rule, and given how complex the web has got with cloud computing and everything that's happening nowadays, a web server is kind of it's not necessarily the primary the primary functioning server anymore. It's been replaced by kind of a whole stack of different technologies, but we'll get into that a little bit later. So all you need to know right now is that Apache was the kind of the end result of the NCSA HTTPD project, and most users of the NCSA server ended up switching to Apache once, when it was released. We will be working with Apache in this class. You will learn how to install it, you'll learn how to configure it, and you'll learn how to make it work for you. It's incredibly powerful, and but it's also relatively simple to use, and it kind of gives you a lot of freedom on how you basically publish to the web. So more on that in a little bit. Okay, so now that we kind of have a very brief history of web servers and how we got here, and there are other web servers besides Apache. It's not just Apache. There are other servers like Nginx and lots of little kind of, I'll call them boutique web servers, and I'm talking about servers like Thin or Mongrel or some of these Ruby-based web servers that we'll get to a little bit later in the semester. So let's park the web server history for right now and kind of move on to where web servers are today. So obviously web servers are incredibly important, both for how we get information nowadays from our smartphones to our computers to basically anything that has a Wi-Fi connection or an Ethernet port. On the other end of that somewhere has to be some type of web server, either feeding it data, communicating in a server-client relationship. Something has to be happening there. Web servers are also incredibly important in our businesses, in particularly and obviously internet businesses. So one of the major kind of booms for web server technology has been the cost of computing. Because the cost of computing has come down so much, we're able to serve more websites, get more performance out of our web servers with cheaper and cheaper computer hardware. And at first, this was just really kind of cheap server-based web hosting, but what this has migrated into is essentially cloud hosting, which is what we're going to be interacting with in this class, but it's made it computer hardware so inexpensive that it's basically commoditized, that we now just rent computing time by the hour, by the minute, even by the second in some cases, and only use exactly what we need. And web servers have played an integral role in that and have become very, very important as the cost of computing has gone down. So let's look at a couple of case studies on where the cost of computing and web server technology has taken us in the business community. Google. Google operates the largest search engine on the planet. They index billions and billions of websites. And when you go to google.com, it's probably the fastest site to load on the web. And I don't care if that's just Google's homepage or news.google.com or any of the Google subsidiaries. And that is no accident. Google has spent millions and millions of dollars making their web servers some of the fastest in the world. Now, Google uses very complex systems. I'm sure they have Apache installed some places, but for the most part, Google kind of rolled their own system. They have their own systems in place. But the type of scale that Google achieves is only doable with the current cost of computing. And they use commoditized servers to scale out their platform relatively cheaply. In fact, Google basically is built on cheap computer hardware, like run-of-the-mill hard drives, RAM, and motherboards that you can buy at Best Buy or off of Newegg. That's what Google uses to run all their systems. And the great thing about that is because it's commoditized, they can just, if a hard drive fails, they can just pop a new hard drive in there that they could literally run down the street and buy retail. And it also means that it's cheap because that computer hardware has come down so much. Because you can now buy a desktop with a 20-inch flat screen monitor for $300, Google can buy that in bulk and at scale and save even more money. So essentially they build these kind of homegrown supercomputers that end up running their entire site. So Google is a poster child for the decreased cost of computing and the increased performance in web servers. Amazon. Amazon is one of the largest e-commerce sites in the world on the internet, and they are everything from books to music to videos to anything you can think of. I probably order 90% of my online mail order stuff comes through Amazon. So they're a very, very big deal. So Amazon uses similar computing as Google in terms of it has to scale out with server technology. But the interesting thing about Amazon, and something you may not know, is that Amazon also hosts most of the cloud-based web. And they do this through one of their services called Amazon Web Services. And these are essentially cloud and commoditized servers that you can buy by the hour. And you can scale to supercomputer-sized performance for just an hour or two while you do a scientific work or process a large data set or something like that. So Amazon really pioneered the kind of programmable, scriptable web server cloud applications that you typically see. Amazon Web Services are the foundation of really great hosting like Heroku. They are the foundation of lots of internet startups. They're the foundation of Netflix. Netflix has one of the most complicated implementations of Amazon Web Services out there. But the cool thing about what Netflix does is they use Amazon to distribute their platform across the world, so they achieve redundancy and business continuity. When one particular region might go down, another region can come up and take over where we left off. We're going to talk more about Amazon throughout this class, but they are key elements in the development of advanced web servers and advanced kind of web systems and stacks on the web. Twitter. Twitter is one of our more recent additions to the kind of high scalability web server world. If you guys have been with the platform since its inception, you've probably lived and grown through all of their growing pains, and I include the fail whale in this, or sometimes the site just not being available. And Twitter really struggled early on with kind of rapid user growth, but they didn't expand their engineering and their server infrastructure to keep pace with that, and eventually there were too many users, not enough scalability in their web platform, and they ended up dropping service, not having timelines available, all sorts of growing pains when they initially started. But they eventually figured things out and got their scale taken care of, and now Twitter handles an amazing amount of data each day. And it's been a really long time since I've seen a fail whale. So Twitter has really done a great job of scaling up their web servers and their backend servers to cope with increased load. And again, just like with Amazon, just like with Google, these types of things would not be possible without the rapidly decreasing costs of computing. Finally, kind of the elephant in the room here is Facebook. Facebook has almost 1 billion users, or I think they might even be over 1 billion users at this point, and they have huge web server infrastructure. Facebook actually rewrote the PHP programming language so that they could statically compile the files down on their web servers to run faster. So Facebook was dealing with a scale where a group of Facebook engineers sat around, and to them it was more cost effective to rewrite an entire programming language than to try to deal with the limitations of the programming language as it is. So Facebook has a ton of custom web servers and a ton of custom infrastructure that they use to serve their content. But interestingly enough, Facebook still runs on PHP and MySQL, albeit with lots of other fancy stuff in between. But they're kind of the epitome of the huge scale web service that uses seemingly everyday technologies. And we'll talk again more about Facebook as we go through this semester. So just keep in mind with these companies exactly how they're able to serve as many users as they do and maintain profitability. These types of companies would not have been able to exist 10, 15 years ago because the cost of computing would be just too high. The types of processing and the amount of users that these companies, these websites want to serve would have been cost prohibitive with our current financial models with web companies, most of these being ad-based financial models. So the decrease in cost in computing translates directly to these businesses being viable and being able to exist and maintain themselves without having the users pay via ad revenue. Okay. So we're going to stop here and continue this in the next video. Moving forward from here, we're going to talk about kind of a real quick rundown of how a web server works, and we're going to get into a little bit of details about the shell, the terminal, rack space, and kind of what you can expect for the rest of the semester. So we'll see you in the next video.